All right, welcome to Computer Science 4422, software testing and formal methods. Today we're going to talk about kind of a wrap up of the first 5 chapters of the book, and we're going to talk about the fault, error, and failure model. Once again, just to be sure that everyone is clear on what we're talking about. So, basically, the outcome will be to ensure that you know the difference between software faults, errors, and failures, and can be able to describe and use the RIPR model. So, inspirational quote for the day, of course. This is an anonymous quote. All code is guilty until proven innocent. So, thinking about that, right, until we actually have tested our code and verified it, we cannot necessarily trust that code. Furthermore, this applies to things like libraries, APIs, etc. If it comes from other places, you need to have some assurance of what its value is, or its whether it's been tested or not. Always be looking for that whenever you're using open source and or other libraries. So, anyway. Go back to software faults, errors, and failures. We've already talked about this, but just to make sure you understand. Remember, a software fault is a static defect in the software. It was there from the beginning. Software failure is an external incorrect behavior with respect to the requirements or other description of the expected behavior, right? So this is an apparent failure to meet the actual requirements. And of course, a software error is an incorrect internal state that is a manifestation of some fault, okay? Be thinking about that. Okay, a defect is something, a software fault, a defect in a static defect in the software, right, is poorly written code, but it's code that also does not meet the underlying requirements, okay, which then causes an error, as opposed to a software failure, which is external incorrect behavior with respect to the requirements, but that is from external, it's not internal to the actual system. Faults in software are equivalent to design mistakes in hardware. Software, remember, does not degrade. Okay, unlike hardware. So we have a fault and failure model, the RIPR model, right? There are 4 conditions necessary for a failure to be observed. 1, reachability. The location or locations in the program that contain the fault must be reached, right? If you can't reach the fault, then you're not observing a failure from that fault. 2, the infection, right? The state of the program must be incorrect. Okay? If we are to make a claim that we have some sort of a failure, we must have an incorrect program state. 3, propagation. The infected state must cause some output or final state of the program to be incorrect, right? Think about this. We're talking about failure. It's external and observably behavior that's observable. So if we can't actually get any output to where we can observe this failure, then we actually may not have a failure, right? Finally, we don't actually have a failure at that time. Finally, we can the reveal. The tester must observe part of the incorrect portion of the program state. This is later aspect. So when we're actually thinking about how we're actually using this. So the RIPR model, as we just talked about, basically this is how it works, is we have, essentially we start with a test. The test gives some sort of input that reaches the fault. The fault then infects and creates the error program state. That error program state then propagates to the incorrect final state. That final state is then observed by using test oracles to compare against and reveal that observed final program state. Okay, so the incorrect state must be a part of the final program state. The observed final program state, as shown to us and compared against by our test oracle, must reveal that fault. Okay, reachability, infection, propagation, revealability. Think about these things. Okay. All right. As always, if there's any questions, please stop by my office, email me, or come to class and ask questions.